Hey, thanks everyone for joining the session. I appreciate that you took time in this busy weekend to attend this session. So during this session, I'll be, talking about how to forecast new product launches, basically on, data-centric approach. Uh, so this is the agenda of the session. So we'll first discuss about what is new product launch, and then we'll understand what is product life cycle, and then we'll go a bit deeper and try to understand what is the data pre-processing techniques available for this particular problem statement. We'll not dive much deeper into the machine learning pre-processing side because I believe you already know that thing. So we'll talk about pre-processing technique, which is applicable for this particular problem statement. And then we'll understand how to create launch curves and how to utilize that for forecasting new product launches. And we'll also see how the launch curve looks like and what are the different components of it. And almost in the end, we will see how the entire forecasting pipeline of new product launches looks like, and we'll dive deeper into this as well. And then and summary will be there, and then if time permits, we'll have a Q&A session for 10 to 15 minutes. Okay. So let's start with my intro itself. So my name is Surya Tripathi, and I'm working as data scientist at IBM. And from couple of years, I'm involved in the forecasting side, because this is something that is very much aligned with what machine learning real use cases are for the industry. Yeah. So nowadays I'm working in forecasting side, and in my 8+ years of work experience, I have got opportunity to work in Python, R, SQL, machine learning, forecasting, data science, and also in the operationalization side of the machine learning, which is nowadays known as MLOps. So the tools like Docker, Git, I have utilized for MLOps activity. And I also have a hybrid cloud experience, and I hold a couple of data science and machine learning certifications offered by Google Cloud, Azure, AWS, and IBM Cloud. Here is the QR code, which you can scan to connect with me on LinkedIn. And my hobbies are cooking and reading. So let's not spend much time here and move to the main agenda. So starting with new product launch, the first question comes in: what is new product launch, right? And then what is the prerequisite of this particular new product launch, and what are the challenges associated with this, right? So new product launch is like when you introduce any particular product into the market, any product, be it any beauty item or any fragrance, or I'm taking the example of F&B side. So if you take that kind of product and introduce that into the market, that is called new product, right? And when you're launching it, it's like new product launch. So the overall, it's like either a completely new product you are launching, or a variation of that particular product which already in your portfolio, you are enhancing that and launching that. That's that kind of that kind of product is basically known as variation of any existing product. Like, so new product launch could be like completely new to the world, or extension to your product line. So yeah, this is how the new product terminologies are. And now coming to the prerequisite for forecasting, right? So when you forecast something, you need data, right? Your training data, or we call it as a historical. Like let's say you want to forecast a particular item, then you need data from the basically for the training, the past data or training data you need. And that training data is if able to have a kind of lot of pattern in that, then it is very helpful for you to learn that pattern, and based on that pattern, you then understand the pattern. And once you understood the pattern, your machine learning model or your forecasting model forecast for the forecast, whatever forecast horizon you have. The forecast horizon is nothing but how many time steps in the future you want to forecast. So the first thing which you require for any machine learning or forecasting algorithm is to feed the historical data, right? But in our case, this product is newly launched, right? New product launch. So if it is just launch or about to launch, in both the cases you will be maximum data points. If you consider it, it will be hardly 3 or 6 data points, right? So those data points are not, you know, enough to learn the pattern inside the data, because let's say the seasonality is you know, 12 months, right? So after each 12 months you see seasonal you know, repetition in your cycle, and but you have just 2 or 3 data points, and that is not good enough to understand the seasonality as well, right? So this seasonality is just one parameter I'm talking about. There are n number of parameter when you talk about you know, the learning point of view of a machine learning. You require a lot of data points that describe your past activity, how your business has done in the past, how it is doing, how your product has performed. All those data, the more data you'll be having, better insight you can learn, and based on that, better you can forecast. So this is the one thing that require kind of prerequisite for any forecasting algorithm, be it Sarima or any machine learning algorithm or any deep learning algorithm. Any algorithm, the data is required, especially for your custom business problem statement. Now the challenges which we have already talked about, is a newly launched product, so you don't have a historical, and if you don't have a historical, it is hard to learn and your business, and based on that you forecast, right? So we will see some alternatives what we can, you know, utilize to learn to replace this historical with the data which already have in your data warehouse, right? So we'll talk about that in subsequent slides. Now, before we move forward, let's first understand product lifecycle. I have kept this at a first place because the launch curves which we are going to, you know, create, that is very much inspired from this life cycle. So this life cycle, as you can see, has the 4 stages. First is a introduction, then growth, then maturity, and then decline phase happen. In the y-axis, you see sales values, and on the x-axis time. So basically, you are plotting on sales versus time axis, right? So what happened is, in an introduction phase is the most you know, basically the first phase, when you work with your product teams, your marketing teams, your you know, you decide marketing budgets, how much marketing budgets you are going to ingest into this particular launch. That comes into the introduction phase, and this is the very critical phase, because if your, you know, introduction phase is a kind of phase wherein you are telling your audience to that you are introducing a new product into the market, and you know, wider will be your audience, better the chances are that your product reach will be very good, right? If your product reach is very good, the chances are you know, lot that your product sales will go high. Obviously, I mean, quality of the product is matters a lot, but these are the some, you know, key factors where audience reach is also required to get a good uh, amount of sales. So during the introduction phase, you basically you know, do marketing on a different social media channels like Instagram or YouTube, or some TV channels, right? Or that kind of print media. So during this phase, you do a lot of advertisement, and once it is done, it's like you have made aware people that you have launched a new product. Now you want to see how people are reacting that, right? If people are reacting very you know, you're getting very good response of what you have floated into the market, then your growth obviously will go high, and at some point of time the growth will go, you know, a bit kind of exponential growth you'll be observing. But after a certain point of time, when we say that a maturity has arrived at your product life cycle, that means is your product is now people are aware of your product, and based on your response of what kind of quality you are offering, services you are offering, you will see the constant kind of sales in your product, right? So that's kind of mature phase where you will reach at a saturation level, and after a certain point of time your sales will start declining because of many factors, right? It could be that your competitors are launching similar product, or you itself has introduced a new product which is quite similar with what you have launched in this particular product, right? So you will see the decline in the sales, and once decline is there, either you introduce variation of that particular product, or you will discontinue the particular product from the market, or from the shelves, right? So overall, you start with the introduction, then you grow it, then you mature, and then you decline. When you see that declination is going very rapidly, and it is not worth to continue the product, then you discontinue that from the market. So this is the how the complete product life cycle looks like. And if you want to learn more about how the what is the product life cycle and what are the different activities related to that, I have given a link here, and there are many links available on the web which can explain what product life cycle is. But for this particular topic, the what I mean new product launch, this is what at least you should know. So that's the reason I have kept this particular slide at this place. Now coming to the data pre-processing, like, right? So the data pre-processing, which I was talking earlier in the start of the session, that we were not going to talk much about machine learning pre-processing techniques, right? Because that you already I'm assuming that you are already professionals, and or if you are learning students, I mean kind of that phase. If you are in, you're already aware of how that pre-processing techniques applied into the machine learning side, right? So this pre-processing technique, I have taken an example of the sales data. So let's first see on the top right side, left side, how the sales data looks like. So you have three features basically. One is date, other is item ID, and then you have sales. So date is like let's say item ID 334344 is the item ID. That is your, also in industry it is known as SKU. So this SKU is launched in May 2017. The first sales observed for this particular item ID is May 1st 2017. The first value in the date you see is month, and then date, and then year. So what I had done is, I have, let's say my forecast horizon is 12 months. If your forecast horizon is 24 months, then you have to collect 24 data points from the first observed sales date. So my case, I'm just taking considering a 12-month forecast horizon. So I'm just talking about 12 data points. And based on your forecast horizon, you can vary that data points. Now that you have a date, and then item ID, and then sales. Sales is in units. You can take it as a I have taken it and taken that particular thing in units, and it could be in dollars or anything, depends on how you are monitoring the sales, how you are basically capturing the sales. And then in the end, you see the total sales, which is the basically from launch date, basically first observed sales date to the 12 data points, I'm adding it. Okay, so this is the left side description of the data set. Now when we apply pre-processing, how the data looks like, right? Because this data pre-processing is required if you want to form the launch curve, and we will talk more about launch curve in subsequent slides. So date, we have seen it. So first with month, date, and then year, and then you see month column. I could have used a different label, but I'm sorry for that. It's kind of a base month. It's not like it is directly derived from your date. Is ideally it should be 5, right? But I have taken it as a 1. What does that mean is, because what we will be doing at the time of creating a launch curve, we will be creating launch curve from introduction, right? If you have seen in the last slide that first phase is the introduction, when you have introduced a particular product into the market. So when I'm introducing this particular product into the market, or indirectly I say the first observed sales, this is the first month kind of us for, right? This is the first month, and then what is the pattern in the 12 month, that is after the launch, what is the behavior in the 12-month window. So how this is derived is, I have taken this particular month, and then what is the last data point? Last data point is 4th month, right? If you subtract this particular number, that is 5 minus 4, that is positive, right? If it is positive, take it as it is. 5 minus 4 is 1, take as it is and mention month as a 1. But what if it is negative or less than 0? In that case, when you are subtracting it, add 12 months. So what it will do is, let's say this example, 2 minus 4 minus 2, and then we add plus 12, so it will come 10. So this is how the base month you can derive. This is basically indicates that this particular sales is the first month on the launch, and then in the second month after the launch the sales was this, and the 12th month after the launch the sales was 20,000. Okay, so item ID is again the same, that is also known as SKU, which I have told you earlier. Now sales is what you see in the sales column is absolute value, but to compare different things we need a kind of relative sales. Why it is? Because we want to understand how the sales like this, how this, what percentage of sales is being made for this particular item at its peak, right? So to understand that and compare different item IDs, if percentage we take, it will give a good picture compared to the absolute value, because absolute value will go much higher and then comparison will not that much easy to do. And for that reason I have taken as a relative sales. So how that is calculated, you take this sales value, that is we call it as a 4500, right? And then divide that with the total sale. Total sales, if your forecast horizon is 24 months, then 24 months sum you will be dividing and you'll be reaching out. So if you observe this particular relative sale, you see that in the 6th month of the after the launch, you are going at your peak, right? Kind of you are making a lot of sales. I mean, overall total sale, you are contributing more in the 6th month of the launch, right? So that's what it means. And if this is how it is derived, right? In the second case, when very ideal case is there, right? Your product is launched in the January itself, right? So your month is nothing but if you can just if the calculation which I talked about, if you apply that, that also will produce same number. And this is the ideal case. So first is the first, second month is second month. So that is the case. Both just I try to show you that month is different from what is directly if you get from the date. So that's the reason 2 cases I have covered it here so that you can understand the difference. So that's all about data pre-processing side of this particular problem statement that we'll be talking about more in launch curve. Yeah, so we have seen that, right? How the pre-processing works. And now the main the main task here is to create a launch curve, right? If we are able to create a launch curve and it is very good representative of what you had done in the past, basically in terms of sales, then you are at a very good position to forecast new product launch. If your launch curve itself doesn't make make any sense, means if pattern is not even, right? Some item IDs are going, basically SKUs are going higher in first month of the launch while others are going in the 6th month of the launch. So that kind of is not a ideal case, and that will be not good when you forecast particular thing. So we'll talk more about that in the launch curve section. So let's understand how we can create a launch curve. So you have, let's say in the first step, you need items data set. Items data set is nothing but whatever product you are going to launch or you have launched in the past, that product's attributes. It could have many features like color, weight, category, what is the list price of that particular item, and then what is the start date, and what is the discontinued date of the particular item, and category of the product or description of the product, right? So these items usually you get from your items data set. Then in the second step, what you are going to do is, when you have a data set, you will apply machine learning, right? So you will apply natural language processing, because the description is also I'm providing it to you, and some more text kind of feature I'm providing it to you. So to understand that feature better, it is recommended to use natural language processing. instead of going with other approaches. And once you are done the featureization of the particular data set, what you can do is, now it is machine learning basically can be applied, right? Because you have converted all those features, and then perform pre-processing, data pre-processing, specifically at a machine learning side, and then your data is ready for clustering, right? So if I have used k-means in my experiment, you can also use different clustering algorithms and see which one is performing better, and based on that you can pick your algorithm. The one point which might need business input, because the k-means, the cluster you need to define, right? So if you are defining, let's say I'm good at defining 5 launch curves. It's not like the more you define the cluster, the better performance matrix, your performance matrix will produce better number if you increase the clustering segment number, right? So if, let's say, you're performing better at if you go with the cluster, say saving clusters, but saving cluster business is not recommending, business is not fine in with the saving cluster. They want to understand these segments in just 4 or 5, maximum 5. Then you have to use 5 clusters and optimize that according to that particular thing, because at the end of the day you have to communicate this result to your stakeholders as well. And these guys will be mostly on a business side. So in our case, we have applied clustering, and then we have got your item data set have item ID, right? Or SKU ID, we can say item ID, and then cluster, you have got it after applying clustering algorithm. So in the second step, which you have items with clusters, so basically your item ID and then your cluster ID is there, right? So in the third step, which is need not to be in the sequence, you can do it third step in the first place itself, but for the illustration purpose I have used it as a step number 3. So what this particular data set is, this data set is a sales data. So the pre-processing technique which we were talking about, in that the tabular representation was there, right? So that tabular representation is nothing but is a kind of your sales data, how your sales data will look like, that particular representation I have shown in that particular slide. So that pre-processing, once you are done with that, you have item ID, you have relative sales, and right, these two things will be there. And and once you join this second step and third step, this data set will provide you the sales data with cluster, because item here the joining key is item ID, right? So item ID, when you join, you will get how much sales it has done in the first 12 months after the launch, and what is the cluster it belongs to. So when you have a cluster ID, you can just pick one cluster, let's say cluster 1, and you will get all the item IDs of cluster 1, along with the month of launch, right? 1, 2, 3, and 12. So and relative sales. So when you plot this, it will look like this. So when any new product is being launched, in that case, what you can do is, first thing you are going to get is first thing you are going to get is a cluster, right? Once you get the cluster, you go to that cluster's launch curve, and when you have that launch curve, you can just average it out, this particular whatever data present there, just take average of that, and you can say this is what you are expecting new product to behave like, right? I have framed this particular problem statement in this kind of unsupervised way, but yeah, the same thing you can do is in supervised way also, right? You can just form a data set with the clustering, right? With the clustering, you have like is kind of clustering number is kind of label for you when you are going to form this with the supervised way. Clustering label is kind of your target, right? And then other features which are there, like your items and other things, will be your features for the training. Now you train that model, and your model will able to learn that this is for this particular feature, this is the target. So when you ping when you basically query, let's say for this particular item, I have, let's say I'm launching a new product which has these item attributes, okay, and what your supervised model is going to predict whether it is first cluster, second cluster, or third cluster. Based on that you will get cluster, right? So that is the one way. Now I have taken a very simple approach to just take the average and say that how this particular launch curve is going to perform. Other way could be you can apply curve fitting algorithm, kind of regression algorithm, wherein you will fit uh, um, kind of curve on this particular data set, right? Though it is looking at a graph, but it's a data set, right? It's a data set. When you fit it, let's say you are observing this upper side, here you are observing, then you can say that for this particular target, I'm getting this particular cluster. So there are n number of possibilities you can play with, and whatever is going to give you best result, that you have to choose. So in my case, I have gone with the clustering algorithm, and I just taken as a average because of the time constraint I had to deliver this particular piece. But in your case, you can try with different things like fitting curve there, and then understanding what is the sales distribution looks like. So this is what overall how to create a launch curve. So main piece is there: first predict a cluster, first to cluster this particular data set, and then perform pre-processing, then join the data set, and then for each cluster when you plot it, you will get it a launch curve. And now coming to launch curve, how it looks like, right? So the one I'm talking about. Yeah. So relative sales, you can see on the y-axis, month is nothing but your from the launch month, what is the numbers looks like. That is one indicates that it is first sales observed in the this particular month. And then after the launch month, this is second, means after the launch month, what is the number that second indicates. Now to see here, it looks like this particular this looks like a product life cycle, right? It is first introducing into the market, and then going growing, and then declining, then again growing and going to peak, right? And then start declining, and then it's very constant and almost dying it, right? And then you can decide whether you want to discontinue it, or what that it indicates, right? That's we have seen in product life cycle. So that's the reason product life cycle was covered, because it indicates how the launch curve we are going to create. Now this particular thing, if you see, there are different values, right? If you, one particular item is going like this, second is like this, third like this, but overall, if your sense you are getting, most of the items of this particular cluster is getting making good amount of sales in the 6th month after the launch, right? And then after the 12 or 13 month after the launch, it's almost dying. So that's what a launch curve gives you a picture about how your sales product is behaving. Now this is very ideal case. Ideally, if your data set is very good, you might arrive at a very tight clusters like this. But like this, basically tight clusters, what I mean is, so what happens if it's not ideal, right? If it is, you see here, right, this is again following same trend. But if it is not ideal, you might arrive at a lot of curves which is looks like this particular orange line. It's very bad launch, I would say, because in the launch month itself, you are just making less than 0.1% of sales, and then it's almost constant, then below that, and then suddenly dies out, right? So this is a kind of situation wherein, let's say, your data set which you are plotting in looks like this, but you're not able to understand the pattern like this. If there are a lot of points, then what you need to decide is, first you need to understand what is happening. It could be the case that this particular item is very costly item they have launched, and either it is and that also can be possible that this particular item is not for everyone. It is for very exclusive peoples, right? Very premium customer, I would say. And that's the reason you see a different pattern in the sales compared to the what other data points are showing. So in this case, if your uh, launch profiles are not very much basically not looking very good, in that case what you can do is you understand the data points and understand why something is deviating from the population. In that case, what you can do is you can have a call with business and try to understand what were the keys for these data points, and if required you can exclude these data points, because there's no point if you're representing a wider audience and there are a couple of data points which is very specific to people, then you cannot generalize it, right? So in that case, talk to business and understand if you can exclude those data points from your analysis or learning, and based on business call you can do it and uh, take the actions. So this is how the launch curve looks like. So it's nothing but your product life cycle, how your item has basically performed over the uh, you know uh, um, years after the launch. Now coming to the how new product launch forecasting pipeline looks like, right? So first, basically on the top you see the training pipeline, and in the bottom you see the inference pipeline. I have not made it make it very complicated. I try to make it very simple so that you can just digest this particular piece very easily. So at first place, in the starting from left on the top on training side, you have different items. For indication purpose, I have shown the items like beauty items and fragrance item, right? Some nail prints you see, some fragrance you see, and then sales data is there, right? So all these at one place. When you get it, this particular data set, what you do is what we have seen in the how to create launch curve, right? So you will perform pre-processing specific to this problem as well, and also at machine learning side. I mean, that data sets should be tweak uh, uh, should be converted in such a way that it should be consumable by your machine learning model, right? So I have applied data pre-processing which is at this particular problem specific to this problem statement, as well as on a machine learning side. And once that is done, you are able to perform basically create a launch curve. Let's say I'm going with 4 launch curves. Okay, that means 4 clusters, right? 4 launch curves are there, and then my whatever models I have used to form this particular thing, that model is also there, right? So this is about training pipeline. Now at a prediction or inference pipeline, what is there? Let's say I'm launching a new product, and that when I'm launching a new product, you don't have sales data, right? You have just item attributes, like what kind of item is there, what description of item is there, what is the price, list price, I mean launching price of the particular item. All these details you have. Now what you do is you will perform some pre-processing which you have already applied on the training side, and then pass this to ML model that will give you which particular launch curve should be ideal for this particular new product launch. Then you will get in the second step, you will get the launch curve. And once you have a launch curve, you can just take average of that particular launch curve and say that this is how your sales distribution looks like, or you can also extend this particular steps to next step. Instead of taking average, apply even more algorithm there to basically fit a particular uh, curve into your launch curve. So that could be other way to do that. So this is how your training and entrance pipeline of new new product launch looks like. Now I mean, this is also helpful for a launch curve, not at I mean, you also talking about what could be the retraining frequency, right? Which I missed to talk about that. So retraining completely depends how many data points you are inserting into your pipeline each month, because each month you will be not if each month each quarter you will be introducing new launches, right? If you are launching new items in each and every quarter, the numbers is very high. In that case, after a certain point of time, that particular new launch is going to be matured, right? So it's like those data points can be utilized as your training points, right? So it depends, I mean, whether you want to keep it that particular thing at a quarterly or 6 month or 12 month. It totally depends how many what is the volume you are inserting each month. So this is about new product launch forecasting pipeline. Now, this is all I had to present today on a new product launch. So what we have seen is what is new product launch, and how to use existing product launches to forecast new product launch. We have talked more about how this kind of technique is very helpful when you are extending or kind of variation of already launched product you are introducing into the market. If it's completely new, or it's kind of extension to new product line, right? If it is completely new and the data point itself is not there, then you have to wait few months, and when that phase is over, after that you start collecting the data, and then you can apply this particular approach. We've also seen product life cycle, what it is, how it looks, and how that going to be critical, basically useful for us. We have also seen data pre-processing specifically for this particular problem statement for creating launch curves. And then we have seen the steps to create a launch curve, and in the end we have seen the forecasting pipeline, how it looks like, right? So yes, that's all I had today to present, and now I'm open for a Q&A. Thanks a lot again for taking time to attend this session.
So, sir, one question is from Akash. He is asking, when we are talking about forecasting a new production, it is to be
Mhm,
done before the launch, right? So, like with no historical data,
mhm.
what which makes it a cold start problem. So, can you tell me a solution?
The same thing we have talked about, right? If it is a new product launch, the one thing I think you missed is we are utilizing existing product launches, right? Because all of the kind of historical data which we are using is all the data which has launched in the past. Okay, and once that learning you have, when you are something new you are launching, what you will do is you will find the clusters, and based on that you will say this is going to be look like for this new product launch. Did I miss something, or the question was different?
No, sir, it's fine, sir. Actually, the another question is from Janet.
Mhm.
So, he is asking, what is the clustering algorithm is the best to try with?
But the baseline would be the k-means, and then there are n number of things you can try, right?
Another question is from Razvan. So he is
Mhm,
asking if there is no historical data regarding other product launches. So
mhm.
which would be the best way to perform the analysis?
Then you don't have data itself, right, on what you will perform analysis. Then what the best approach in this case could be, uh, you try to purchase data from of your competitors, what they have if they have launched similar products, right? It's not something very new you are introducing in the market which is not offered by any other your competitors. So what people do in this case is they procure data from their competitors, and that data they try to study, and based on that they create their strategy. This is you need to understand, this is the one way, this is not the only way. Okay, when I say this is the only way, it is not a correct statement. It is one of the way, because even if you provide this particular solution to your business, they are not just relying on your this particular solution. They will be having four more things, like they are surveying the market, and they are doing analysis on their competitors. There are a number of things they are doing, and along with that they are also imbibing the approach which you are presenting, which we are calling at a data centric approach. Now they are combining all this approach, and based on that they are taking decision. So business decision is not just on this KPI is not like this particular thing. Okay.
So, sir, in addition to the same question, so
Mhm.
he has asked, thank you. What do you think about the synthetic data?
Synthetic data, I mean, it depends. I mean, uh, how you have created, right? I mean, synthetic, if you could highlight an example, it will be easy for me to elaborate further. Because synthetic data, if you are just randomly creating it, it doesn't make sense. But if you are learning something, and after that you have got some intuition that this data should look like this, and based on that you are creating, then it is bit good. But again, this is better than your synthetic approach.
So another question is from Prashanta Kundu. So he is asking, sir, do you have a solution workflow for forecasting? Can it be shared?
Come again, please, I missed that.
So he is asking, sir, do you have a solution workflow for forecasting? Can it be shared?
See, currently the main challenge is the data set. The data set, the open source doesn't have this particular problem statements data set. Let me figure it out. If I find a particular data set, then definitely solutionizing won't take much time and I can provide to you. But the client data I cannot share with you, unfortunately.
So, sir, another question is from Hussein. So he's asking, sir, since we are using product description as one of the features while clustering initial
Hmm.
learning,
Hmm.
so we see there could be a lot of noise. That is, the text feature would increase.
Hmm.
Then this would lead to incorrect clustering. So any suggestions or guidance on this?
Yeah, I mean, good point. So see, first of all, you need to let's say example of fragrance and beauty items, right? If you try to cluster both item in one particular approach, it is difficult, right? Because fragrance description will be kind of different compared to the beauty items descriptions, right? So in that case, what you can first step is do this that segregation. I mean, do the segregation at a product line basis. Product line means your fragrance will go into the one different pipeline, and your beauty items will go into different pipeline. Now, coming to the fragrance itself, right? When you describe fragrance items, whatever perfume it is, if you are describing the description would be quite similar, right? What especially you can offer a better fragrance, like that, right? So that when you segregate that on a product line basis, the chances are there that similar item will have almost similar product description. Name is a different thing, but description will be almost similar, you will find.
So, so he's replying with that he got to understand that basically to add a SKU category while clustering is the best
Yes,
option.
yes. I won't say SKU category, I will say product line category. Okay, SKU category is a different thing. Product line category is what your SKU belong to, which product line, whether it's a beauty kind of item or fragrance. Inside beauty also, it could be skincare or makeup product, right? So there are a number of things. If you dive deeper into the segment, you will find. See you guys.